In this section, we'll take a look at the Configuring and Monitoring OSPF objective of the JNCIS Service Provider exam. We'll examine how to configure multi-area OSPF, how to redistribute routes into OSPF, and how to troubleshoot OSPF. For more detailed coverage of this objective and more, please check out the JUNOS Intermediate Routing course. In this video, we're going to continue using this network topology, and we're going to use it to demonstrate OSPF concepts. So what we're going to have is we're going to have a multi-area OSPF network with R1 and R2 being in non-backbone areas and every other device being in the backbone area. In fact, this diagram best highlights what we have. And I've done some pre-configuration on this network already. So we have our backbone area, area 0, consisting of routers R3 through R6. And we also have area 1 and area 2 interconnected to the backbone area via R3, which is acting as the ABR for this network. And all of area 0 and area 2 has already been pre-configured. So what we're going to do is we're going to add R1 to our multi-area OSPF network, and then we're going to see how this affects routing on the network. So let's just take a look at the configuration that we've currently got on R3. See, we have our backbone area configured, and we have two other areas configured, area 1 and area 2. And so we've got OSPF neighbors over the interfaces in area 0, and we've got one OSPF neighbor to area 2, but we're missing the one to area 1, which is what we're going to add now. And what we're going to look to complete is we need to get to a full topology of loopback addresses. So if we look at the route containing all our loopback addresses, we've learnt via OSPF the loopback addresses of router 2, 4, 5 and 6, but we're missing router 1. So let's go and add that now. And if we have a look at the routing table on R1, see that it's very empty. Got nothing configured for OSPF. So let's get that configured now. See what interfaces we need to be working with. First thing that we do is we're configuring the interface facing R3, which is our ABR. We also need to add our loopback interface. Just show you this is our loopback interface. And with this configuration here, it's not mandatory, but it is highly recommended, and that is to explicitly configure the router ID, which is what we're going to do now. So the configuration modifications that we've got in place, we're adding OSPF configuration for area 1 with our interface facing into router 3 and our loopback, and we're specifying the router ID. So let's commit this configuration. And there we have the OSPF neighbor has come up to router 3. And we can see the OSPF interface is configured. Let's have a look what effect this has had on our routing table. We can see all of these OSPF routes have been learnt. And we can see all of the loopback addresses of the devices within our network. So you have router 1 through router 6. Let's see if the opposite is true on R3 now. Do we have the route for R1? We do. That's the basic configuration steps that you need to go to configure OSPF. Before we leave this video, let's take a look at some of the more detailed interrogation of OSPF that we can do. Let's have a look at the OSPF database. And in the OSPF database, you can see all of the various different LSA types. So within our area, we have type 1 LSAs that have been announced by ourselves, router 1 and router 3. We've got a type 2 network LSA, so that's the originated by the DR on this link that's enhancing the information that's carried within these router LSAs. And then for all other destinations in the OSPF network, we've got network summary LSAs, type 3 LSAs that have been advertised to us by the ABR by router 3. If we use the detail flag on the OSPF database, and if we take a look at the type 1 LSA that we've announced ourselves, you can see that it contains the links that we're aware of. So it's got our loopback interface in there, and it's also got the link that's connecting to router 3. You can have a look at the type 2 network LSA, telling us what routers are connected on that broadcast segment. And then for all other information, we have type 3 summary LSAs. And this is an overview of the basic configuration for OSPF and some operational commands you can use to interrogate OSPF state. In this video, we're going to take a look at redistributing external routes into OSPF. So we have our multi-area network that we took a look at in the previous video. And what we're going to be doing here is we're going to be redistributing the interface route that's interconnecting XR1 to R1 into OSPF, and that route is then going to be advertised throughout the network. So we'll first apply the routing policy needed to redistribute this route, and then we'll examine the routing tables on various routers throughout the network to see how this route looks on those different routers. So let's go and apply this configuration now. So on our router 1, we just have our standard OSPF configuration that we applied in a separate video. So let's first find the route that we want to advertise. So it's on this interface here. And it's going to be this route that we're going to be advertising. We can see it in our routing table as a direct route. Just to confirm that it's not actually in anywhere in the routing table on other routers in our OSPF network. It's not on R2 in area 2, and it's not on our ABR R3 that's interconnected to all three of our networks. So let's now configure a routing policy to redistribute this route into OSPF. Very simple routing policy. Just got one term, and we're matching based on an exact route filter match onto that route. So all we need to do now is to apply this to OSPF under export. So we have this applied under export now, and let's commit our configuration. And then what we can do is we can hop onto a router in area 2, and we see that we now have this route in our routing table. One key thing to note here is because this is an external OSPF route, we have a different route preference than our internal OSPF routes. So you've got a preference of 150 compared to a preference of 10. Let's just confirm that this route is on other routers in the network. So we can see it on our ABR on R3. And we can see it on the far end of area 0 as well on R6. Let's just go back to our diagram. So we can see the route here, here, and here. So it's definitely flowing from R1 into both of our other areas within our network. So let's see what's facilitating this routing flow. We have a look on R2. Taking a look at our OSPF database again, we've got two new LSAs here. We have the type 4 ASBR summary LSA, which has been announced by the ABR interconnecting to area 1. In this case, this is our router 3, and he's telling us how to get to the ASBR, how to get to R1, because R1 is redistributing the route. And then we have our type 5 LSA, and that's the actual redistributed route itself. If we do a detail on the database, these are those LSAs, but with a little bit more information in there. So that was a very quick demonstration of how you can redistribute routes into OSPF. In this video, we'll take a look at a couple of quick OSPF troubleshooting tips. So we've been away from the network for a while, and we've come back and we have a look at R1, and R1 has no longer got any OSPF neighbor relationships. So we need to troubleshoot why this is happening. So let's hop onto R1 and see what the situation is. See, there we go. We've got no OSPF neighbor. Does look like OSPF is still configured on an interface. Let's just check our configuration. Yeah, we still have our OSPF configuration on there. So the first thing that you can do is that you can run a TCP dump, run a monitored traffic interface on that OSPF speaking interface. See if we are receiving any OSPF protocol messages. So we're matching on the remote IP address, our neighbor IP address, and you can see that we are receiving OSPF hellos on this interface. See, this is the remote IP address. We've got an ARP entry for it. And so we're definitely receiving OSPF hellos. So there's something more granular going on. The neighbor hasn't been deactivated. So what we can then do is that we can then turn to turning on trace options. I've done this ahead of time. So under protocols OSPF, we have trace options. We're specifying a file where we want to store the log messages. I've got a flag of error turned on and a flag of event turned on. So let's have a look at this log file based on that neighbor IP address. So can we find anything in our log messages to indicate what's going on here? We're receiving a hello message. This corresponds to what we're seeing on the TCP dump on the monitor traffic interface. We're receiving those hellos. But the interesting piece of information is here. See that the hello that we've received has been ignored. This is because the sending device is identifying itself as being part of area 0, and we are configured for area 1. So this means that somebody's been onto the ABR and has done a misconfiguration. We can confirm this by looking at the ABR, and we can see that our corresponding interface has moved from area 1 to area 0. So that's the configuration error that's happened. We can correct that. And then we can go back to R1 and see if we now have an OSPF neighbor. We do now have an OSPF neighbor on R1. So that was indeed the issue. There was an area mismatch, and that was causing that neighbor to be down. And these troubleshooting tips can be applicable to detecting lots of other OSPF errors when you're trying to establish a neighbor. One of the first things to do is to see if you are receiving packets across the interface, and then you can move that troubleshooting on further by turning on various flags under trace options and having a detailed analysis of the trace options file that's created when you're logging. And this is a brief overview of some quick OSPF troubleshooting tips.